So in this video, we are going to attempt a year 2021 free response question AP past paper. So first of all, they have a question: methanoic acid HCOH ionize according to equation above. Write the expression for the equilibrium constant Ka of the reaction. So when you are going to write the Ka of this reaction, that is acid dissociation constant, so you are going to have product at the top H3O positive times with the concentration of HCOO minus, and at bottom it is going to be HCOOH, which is reactant, and water, we don't include water because it remains constant. Calculate the pH of a 0.25 molar solution of HCOOH. So we are going to use ice method for that. HCOOH plus water molecule, they are going to form H3O positive plus HCOO minus. So we are going to write ice. Ice means I means initial, C means change, and E means equilibrium. So first we have 0.25 molar solution of HCOH. So I am going to write 0.25 here. And in the initial, the product concentration is 0. While when we are going to write the change, let's suppose the change is going to be X. And if we are going to write change in on the reactant side, so it is going to be minus X. Okay, because the change has been subtracted from the reactant and that would have been added into the product. So if it is 1:1, we are going to write just plus X, and as it is 1:1 with HCO minus as well, so I'm going to write plus X there as well. And then for equilibrium, we have to add above two quantities, so it would become 0.25 minus X, and that would become only X, and here is only X as well. So after applying the formula of Ka, which we have formed before as well, H3O positive times HCOO minus over HCOOH. Ka of the reaction is 1.8 times 10 to the power minus 4. H3O positive is X. HCO minus is also X. HCOH is 0.25 minus X. So here this quantity X can be considered as 0 because as it is a weak acid and it dissociates in a very small amount, so it can be taken as 0. So 1.8 times 10 to the power minus 4 is equal to X square over 0.25, and that would become X square is equal to 0.000045, taking under root on both sides. So the answer that comes out to be is 0.0067 molar. For this part, they are saying for HCOH, write the Lewis electron diagram. So first let's count the valence electron, hydrogen, like we have two hydrogen there. So one hydrogen is having like one electron in their valence shell, so it would become 2 times 1. And there are two oxygen, each oxygen is having 6 electron in its valence shell, so it would become 2 times 6, and that is 2, that is 12. And for carbon we have only 4 electrons, as there is only one carbon, so it is 4, so total becomes 16 plus 2 is 18. So first of all, let's draw the bonding pairs out there. So bonding pair is going to be like this one, And then we have to draw the non-bonding pair. Like for oxygen we are going to have like this for oxygen. Now how many total electrons become? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So total are 18 electrons. But now the octet of carbon has not completed yet. So for completing the octet of carbon, we need to remove two non-bonding electrons from here and we need to put it over here. So now how it will become? So let's draw them in this form. Draw with the line. Draw with the line. And here also draw it with the line. And here we need to draw the double bonds. Yes, so this is going to be our final answer. Then in the next question they are saying write the balanced net ionic equation for the reaction between H2NH2 when it's combined with HCOOH. So how we can write it? H2NH2, which is acting as a base, and HCOOH, which is acting as an acid. So you know acid is a proton donor, so it is going to give this proton to this hydrogen, and then it would become H2N N N H2N N NH3 positive plus HCOO minus. Is the solution acidic, basic or neutral? Justify your answer. So we have two values. One is for Ka and other is for Kb. So if you see the value of Kb, which is 1.3 times 10 to the power minus 6. So Kb is 1.3 times 10 to the power minus 6, and acid dissociation constant is how much there? That is going to be 1.8 times 10 to the power minus 4. So you can see one thing, that acid dissociation constant is greater than Kb. So because of that, you are going to say it is going to be acidic. That is going to be acidic. Why it is acidic? Because the production of H3O positive is more than production of OH minus, because we need to write this thing as Ka is greater than Kb. So because of this, what we can analyze, that there are going to be more hydrozonium ion as compared to OH ion. So this solution is going to be acidic. So in the next question they are saying when a catalyst is added to a solution of HCOH, the reaction represented by the following equation occurs. So is the reaction a redox reaction? Justify your answer. So when we have hydrogen here, hydrogen, when it is combined with any other element except group 1 metal hydrides, it is going to have oxidation state of +1. So hydrogen here is present in elemental form, so its oxidation state is 0. So you can see one thing here, that oxidation number of hydrogen is changed from +1 to 0. So what we can assume here, as there is decrease in oxidation number, so reduction has been taken place on hydrogen. But when we are going to see carbon here, let's find out the oxidation state of carbon. So it is HCOOH, and for hydrogen we are going to put +1, for carbon we are going to put X there. So X is there, and for oxygen There are two oxygen with oxidation number of -2 because it belongs from group 6. So it is going to have the oxidation number of -2 plus 1 for hydrogen is going to be equal to 0. So plus 1 plus x minus 4 plus 1 equal to 0, x minus 2 equal to 0, so x is equal to 2. So carbon is having the oxidation state of plus 2 here. This is for carbon. And for in carbon dioxide, we can do it by x plus 2 times for oxygen is minus 2 equal to 0, x minus 4 equal to 0, and x comes out to be 4. So oxidation number of carbon is changed from you can say is changed from plus 2 to plus 4. So there is an increase in oxidation number, so we can say oxidation has been taken place at the carbon. Then what happened? The reaction occurs in a rigid 4.3 liter vessel at 25 degrees Celsius and the total pressure is monitored. Total pressure is 24 as shown in the graph above. The vessel originally did not contain any gas. So only the gas will be carbon dioxide and hydrogen, and we know that total pressure is going to be 24 atm. And when we want to find out the pressure of carbon dioxide only, we know that carbon dioxide and hydrogen are going to have 1:1, as you can see from the equation. So when we want to find out the partial pressure of carbon dioxide, it will be equal to 24 by 2. So that comes out to be 12 atm. So partial pressure of carbon dioxide is 12 atm. And if we want to find out the number of moles of carbon dioxide, that is equal to PV by RT. P is how much? That is 12 atm, because we want to find out the number of moles of carbon dioxide, and volume is given to us, that is 4.3 liter, and the value of R is going to be 0.08206 liter atm per mole Kelvin times with the temperature, that is 25 degrees Celsius. So you need to do 273.15 plus 25, that comes out to be 298.15. So that is 298.15 Kelvin, and the moles comes out to be 2.1 mole of carbon dioxide. After the reaction has proceeded for several minutes, does the amount of catalyst increase, decrease, or remain same? So we know that the amount of catalyst doesn't change during the reaction, that only increase the rate of reaction by decreasing the activation energy. So we can write that it would remain the same. So we can write that in a catalyzed reaction, the net amount of catalyst remain the same. For the next question, answer the following question about the element silicon and some of its compounds. The mass spectrum of pure sample of silicon is shown below. Silicon, they are given like different isotopes of silicon. Silicon is basically Si, 14 is its atomic number, and like here if you see, it is going to have the 28 as its atomic mass. So they are asking how many protons and how many neutrons are there. So This is atomic number, which represents the number of protons. So proton is 14. And this is atomic mass. And you know, atomic mass is basically, atomic mass is the sum of protons plus neutrons. And if it is 28 and we know proton is 14 and neutron, we can find it out, 28 minus 14. So that comes out to be 14. So it has proton which is equal to 14 and neutron which is also equal to 14. They are saying write the ground state electronic configuration of silicon. So we know that it is going to have electron which is equal to 14. So that would become 1s2, 2s2, 2p6, 3s2, and then 3p2. Two compounds that contain silicon and silicon are silicon dioxide and silicon hydrate. Now they are saying that silicon hydride, that basically at 161 Kelvin it boils, but silicon dioxide remain as a solid. Using principle of interparticle force explain the difference in boiling point. So you need to remember one thing, that silicon dioxide is having the giant covalent structure like diamond, giant covalent structure, and it has very strong covalent bond, while on the other hand silicon hydrate is basically having weak intermolecular force or weak van der Waals force. So it is having weak intermolecular force, or you can say weak van der Waals force. So that's why it is going to have lower boiling point, while silicon dioxide having giant covalent structure, having strong covalent bond, so it is having the high boiling point. How I am going to write the description for it, let's see. So this is a right description, that SiH4 is composed of molecules for which only intermolecular force are London dispersion force, and SiO2 is a network covalent compound with covalent bonds between silicon and oxygen atom. And London dispersion forces, they are much weaker than covalent bonds, so SiH4 boils at much lower temperature than silicon dioxide. So the next question, they are saying at high temperature SiH4 decompose to form solid silicon and hydrogen gas. Write a balance equation for the reaction. So SiH4, when it decompose, it is going to form, basically it's in gaseous state, so it is going to form silicon in solid state. And because they have told us that it is going to be solid silicon and hydrogen gas, which is H2 in gas form, we need to balance it, so I'm going to put 2 here. Explain why the absolute molar entropy of SiS is less than that of H2 gas. So of course, basically in solid state particles are in more organized form, and they are going to be in fixed positions. Particles will be in fixed position, while if you see the gas state, the particles are more dispersed. So how I'm going to write it? If they are more dispersed, that means, disturbance is greater, disorderness is greater. So we can say that's why it is going to have higher entropy. And let me show you the description for it. So this is going to be the right description for it, that H2 molecules are more highly dispersed than silicon atom and therefore have higher molar entropy. Silicon is a solid, therefore its temperature are its atom are in fixed position and are less dispersed and have lower absolute molar entropy. So in the next question, they are saying calculate the value in joules per mole Kelvin of delta entropy. So how I am going to write it? Delta entropy is equal to entropy of product minus entropy of reactant So products, we have got products as silicon. Silicon is having the entropy of 18, plus we have hydrogen, but we have two hydrogen on the product side, so it is going to be 2 times 131, minus entropy of reactant. Entropy of reactant is going to be 205. So the answer that comes out to be is plus 75 joules per mole of reaction Kelvin. The reaction is thermodynamically favorable at all temperature. Explain why the reaction occurs only at high temperature. Because high temperature is required for the reactant molecules to have sufficient thermal energy to overcome the activation energy of the reaction. Basically, activation energy is the energy required to start a reaction. So at high temperature, what happens? The reactant particles, they are going to have sufficient energy to overcome the activation energy. So how I'm going to write it? So this is the right explanation, that at high temperature, which is required for the reactant particles to have sufficient thermal energy to overcome the activation energy of the reaction, which is required to overcome the activation energy of the reaction. So a partial photoelectron spectrum of pure Si is shown below. On the spectrum, draw the missing peak that corresponds to the electron in the 3p sublevel. So first of all, the electrons which are closer to the nucleus, which are going to have the highest binding energy. So from here I am going to start with 1s2, 2s2, 2p6, 3s2, only 3p2 is remaining. That would come, which is going to have the lowest energy, and as it is going to have only 2 electron for silicon, so the graph is going to be like this. In the next question, they are saying, using principle of atomic structure, explain why the first ionization energy of germanium is lower than that of silicon. So let me show you the structure of silicon and germanium first. So they are saying, using principle of atomic structure, explain why the first ionization energy of germanium is lower than that of silicon. So ionization energy is basically the energy required to remove the valence electron. So if you see germanium like valence electron, they are quite more further away from the nucleus as compared to silicon. Silicon valence electron are closer. So you can see one thing, that it is going to have more attraction. Valence electron would have more attraction from the nucleus. While if we see germanium, like germanium, as it is far away from nucleus, the valence electron, so it is having less force of attraction. And you can see there are more shielding electrons there. Shielding electrons are the electrons that are present between valence electron and nucleus. So as there are more valence electrons, so they would be offering more repulsion towards the valence electron. So how I am going to write it? So this is the right explanation, that the valence electron of germanium is in fourth shell. You can see this is a fourth shell. Then those of silicon atom, which is in third shell. Silicon atom is basically in third shell. So it is in third shell. You can see the valence electron are in third shell, which is in third shell. So the average distance between nucleus and valence electron is greater in germanium, because nucleus and the distance between the valence electron is greater in germanium than in silicon. The greater repulsion result in, so because of the shielding electrons, they are going to offer more repulsion towards the valence electron. Thus there will be weaker Coulombic force of attraction between germanium nucleus and valence electron, making them less tightly bound and therefore easy to remove compared to silicon. There's a next question. A single photon with a wavelength of 4.00, so wavelength has been given to us, is absorbed by silicon atom. Calculate the energy of the photon in joules. So formula is equal to E is equal to hv, and V is equal to C over lambda. C is the speed of light. The value of H is given in the paper, 6.6 times 10 to the power minus 34 times with C, which is the speed of light, 3 times 10 to the power 8, and wavelength is going to be 4 times 10 to the power minus 7. Answer comes out to be 4.97 times 10 to the power minus 19 joules. So next question, they are saying a student is given the task of determining the molar concentration of copper sulfate solution using two different procedures, precipitation and spectrophotometry. For the precipitation experiment, the student adds barium nitrate into the copper sulfate, and then they are going to say that they are going to be dried precipitate which are going to form. And what are going to be those dry precipitate? First, they ask me to write the net ionic equation for the precipitation reaction. So when you are adding barium nitrate, which is a soluble salt, and that would be in aqueous form, with copper sulfate, that is also in aqueous form, and they are going to form barium sulfate in solid state plus copper nitrate in aqueous form. So when I'm going to write the equation for them, the aqueous sign will split up, barium plus 2 in aqueous form plus 2 nitrate in aqueous form plus copper plus 2 in aqueous form plus SO4 minus 2 in aqueous form, and they are going to form barium sulfate in solid state plus copper plus 2 in aqueous form plus 2 nitrate in aqueous form. And you know, the spectator ions, they would be cancelled out, copper plus 2, and net ionic equation becomes barium plus 2 in aqueous form plus SO4 minus 2 in aqueous form, and they are going to form barium sulfate in solid state. So these are the precipitates which are going to form, and that is the net ionic equation. So they are saying mass of dry filter paper. First of all, they are mixed together, and then they are going to pass through the filter paper, and on the surface of it we are going to have barium sulfate precipitates, and barium sulfate precipitates would be in solid state. So they want me to find the mass of the moles of precipitate. So how I'm going to do that? As you know, this is a mass of filter paper and dried precipitates, so we need to subtract both of them. So mass of precipitate, mass of barium sulfate, that would become 1.136 minus 0.764, and that comes out to be how much? That comes out to be 0.372, and MR of barium sulfate we can find from periodic table, that comes out to be 233.39, and moles of barium sulfate, we are going to use the formula mass over molar mass. Mass is 0.372 grams, and MR is going to be 233.39, and moles of barium sulfate comes out to be 0.00159 moles. Now they are saying calculate the molarity of copper sulfate solution. For that purpose, we know copper sulfate, this one, and barium sulfate, they have 1:1. Barium sulfate has 1:1 from the equation, and if the moles of barium sulfate is 0.00159, then copper sulfate would also be having the moles of 0.00159, and the volume of copper sulfate that has been given to us is 50 milliliter. So I have to convert it into liter because I need to calculate the molarity. Molarity is equal to mole 0.00159 divided by, so the volume we are going to divide with the volume, and that is basically 50 milliliter. I have to convert it into liter by dividing by 1000, so that comes out to be 0.05, and molarity comes out to be 0.0318 molar copper sulfate. So for the next question, they are saying calculate the volume of 0.1 molar copper sulfate needed to make 50 milliliter of 0.05 molar copper sulfate. So first of all, molarity is given to us, that is M1, and this is volume of the second liquid V2 and M2. So we can use the formula M1V1 is equal to M2V2. M1 is 0.1, V1 we need to find out, M2 is going to be 0.05 and V2 is going to be 0.05. V1 comes out to be 0.05 times 0.05 divided by 0.1, and V1 comes out to be 0.025 milliliter, and that's going to be equal to 25 liter. Briefly describe the procedure the student should follow to make 50 milliliter of 0.05 molar copper sulfate using 0.1 molar copper sulfate. So basically you have to decrease the molarity because it was 0.1 and it was 0.05. That means like molarity is basically equal to mole divided by volume. So basically what you need to do, you basically need to increase the volume of water in it, as so that because molarity and volume they are inversely proportional, so molarity becomes half. So how you are going to do that, like first you are going to take the quantity of 0.1 molar copper sulfate solution with 25 ml volumetric flask. So you are going to take the liquid of volumetric 25 ml volumetric pipette. You are going to use volumetric pipette for this thing. Like you are going to take 25 ml of liquid from this solution. Then you are going to transfer it into a volumetric flask, which is basically 50 ml. This is 50 ml. And when you are going to put this 25 ml liquid inside it, this 25 ml of 0.1 molar copper sulfate, so remaining, as this contains like it has the capacity of 50 milliliters, so 25 ml you have added, and remaining part you are going to add the water. In this way you are going to prepare the 0.05 molar copper sulfate solution. So this is going to be the right explanation for that. So now in the next question they are saying the absorbance of copper sulfate solution of an unknown concentration is 0.219. Determine the molarity of the solution. So 0.219 at graph is going to be around this, and that comes out to be like around, I think so I have made a little bit up, it should be 0.0219 should be here. Yeah, so that is going to be 0.034. A second student performed the same experiment. There are few drops of water in the curvet before the second student adds the copper sulfate solution of an unknown concentration. Will this result in a copper sulfate concentration for an unknown that is greater than, less than, or equal to the concentration determined in part F? So, of course, when there is a water in the curvet, then what happens? The concentration will be less than determined in the part F, because the additional water will decrease the concentration of copper sulfate in the curvet. Therefore, it would decrease in the absorbance. So, how I am going to write it? So this is going to be the right explanation, that when the concentration, like as there is a water in the curvet, so the concentration will be less than it was determined in part F. The additional water will decrease the concentration of copper sulfate in the curvet. Therefore, there will be decrease in absorbance. So for the next question, a student investigates a reaction used in hand warmers represented above. The student mixes iron solid with a catalyst and sand in a small open container. The student measures the temperature of the mixture as the reaction proceeds. The mixture Fe catalyst and sand has a total mass 15 grams and a specific heat capacity of 0.72. Calculate the amount of heat absorbed. So we are going to use Q is equal to mc delta T. M is the mass, which is 15 grams, while specific heat capacity has been given to us, that is 0.72. Delta T for 0 to 4 minutes, like from this point to this point. So this is going to be final temperature and this is going to be initial temperature. So what we can do here, like initial temperature and final temperature, they are going to be subtracted. 39.7 minus 22.0, that comes out to be 190 joules. And in the next question, they are saying calculate the mass of iron in grams that reacted to generate the amount of heat calculated in part A. So we know there is a formula that is equal to enthalpy change is equal to Q divided by number of moles, as we want to find number of moles there. So Q divided by enthalpy change. So for this, Q is equal to 190 joules and enthalpy change has been given to us, that is 1650, and that comes out to be number of moles, that comes out to be 0.00012. So these are the moles. But there are, in the reaction, if you see, there are 4 moles of iron and these moles are for 1 mole. So for 4 mole of iron, you are going to multiply 4 with 0.00012, and that comes out to be like we can find out the value, that comes out to be 0.00048. These are the mole of Fe, and we have the moles of Fe. So for mass, we are going to multiply mole 0.00048 by molar mass, which is 56, and the final answer comes out to be 0.027 grams. So in the next question, they are saying in a second experiment, the student used twice the mass of iron as that calculated in part B, but the same mass of sand in the first experiment. Would the maximum temperature reached in the second experiment be greater than, less than, or equal to the maximum temperature in the first experiment? So in second experiment, as we are using greater mass of iron, so definitely uh, the temperature reached in second experiment would be greater. Why it's greater? Because there will be a greater mass of iron, which provides a greater number of moles of reaction, which would transfer a greater quantity of thermal energy to the same mass of sand. So how I'm going to write the explanation? So this is the right explanation, that the maximum temperature would be greater than, as greater mass of iron provides a greater number of moles of reaction, which would transfer a greater quantity of thermal energy and would lead to a greater maximum temperature. So in this question, they are saying they have given us an electrolytic cell in which we have magnesium and chlorine, and we have MgCl2 in molten form. So MgCl2 in molten form, that contains Mg plus 2 ions and Cl minus ions. So what happens in electrolytic cell, there is a rule that cations always go towards cathode and anions always go towards anode. So chloride will go towards anode. So this is anode and this is going to be cathode. So first of all, they are asking us draw an arrow on the diagram to show the direction of electron flow through the external circuit as the cell operates. So chlorine is an anode. So electron will be produced from here and would travel towards cathode where they are going to accept electrons. So equation is going to be 2Cl minus is going to be form Cl2 plus loss of 2 electrons, whereas Mg plus 2 would be gaining those 2 electrons and would be forming magnesium solid. In the next question, they are saying, would an applied voltage of 2 volt be sufficient for the reaction to occur? As this is a cathode, because electrons are accepting here, and this is going to be anode. So we know a formula, E naught is equal to E cathode minus E anode. So E cathode is minus 2.37 minus anode is 1.36, and the answer comes out to be minus 3.73 volts. And you can see one thing, that your answer is going to be no. Why no? Because 2.0 volt is basically less than 3.73 volts. So what we can say here, which is the maximum voltage, for electrolysis to occur. If the current is in the cell is kept at a constant 5 amperes, how many seconds does it take to produce 2 gram of magnesium liquid at the cathode? So first of all, we have mass of magnesium. We are first going to find the mole of magnesium. Mole of magnesium is 2 grams mass over molar mass is 24. Okay, and what we going to do, 24 gram per mole. And we know one thing, that 1 mole of magnesium contains how many electrons it is taking? It is taking 2 mole of electron. So 2 mole of electron will come here, and this mole of magnesium will be cancelled with this mole, this gram will be cancelled with this gram, and the answer would comes out to be 0.165 mole of electron. Now 0.165 mole of electron, we know that 1 mole of electron contains 96,485 coulomb, and as we are having like 5 coulomb per second of current, so it is second will come here, and this coulomb will be cancelled from this mole of electron will be cancelled from this mole of electron. So final answer comes out to be 3180 seconds. A student is carrying the properties of calcium sulfate and lead sulfate. The student has sample of both compounds, which are white powders. The student tests the electrical conductivity of each solid and observe that neither solid conducts electricity. So they both are ionic compound in solid form. They are ionic compound in solid form, and ionic compound do not have free moving ions in solid states. So ionic compound do not have do not have free moving ions in solid state, so they can't conduct electricity. Can't conduct electricity. Ionic compound has a property that they can conduct electricity only in molten form or in aqueous form, because only in that state they are going to have free moving ions, not in the solid state. So in the next question they are saying the student places excess calcium sulfate in a beaker containing 100 milliliter of water and place excess lead sulfate in another beaker. So in one beaker he has placed calcium sulfate, and in another beaker he has placed lead sulfate. Okay, this is lead sulfate. So then what he has done, the student stirred the contents of the beaker and measured the electrical conductivity of the solution in each beaker. The student observed that the conductivity of the solution in the beaker containing the calcium sulfate is higher. What is going to be the reason for that? The greater electrical conductivity of calcium sulfate solution relative to lead sulfate solution means that the dissolution of calcium sulfate would be more, and you know that electrical conductivity exists because of the free moving ions. Then when calcium sulfate would dissolve in water, it is going to have more free moving ions as compared to lead sulfate. So that is why its electrical conductivity is more, because it is more dissolved. It is more dissolved in water and converted into ions. So how I am going to write it? So this is going to be the right explanation, that greater electrical conductivity of calcium sulfate solution relative to lead sulfate solution implies that a higher concentration of ions which comes from dissolution of calcium sulfate from the dissolution of calcium sulfate is going to be to a greater extent. So that means calcium sulfate is dissolved more in water and converted into ions more. So there are more concentration of ions when calcium sulfate is dissolved in a beaker as compared to lead sulfate. So lead sulfate is going to have lower solubility. So the left side of the diagram below shows a particulate representation of the contents of beaker containing the calcium sulfate, and we have to draw it for lead sulfate. So calcium sulfate, as it is more soluble in water, so it is going to be split up more into ions. So for lead sulfate we have to show that there are more ions that are present at bottom. And how I am going to show that? So it is basically showing that left side of the diagram below shows a particulate representation of calcium sulfate, and for lead sulfate it is showing that its solubility is less, so less number of ions are going to form when it is dissolved in water. So this is a correct representation. So the student attempts to increase the solubility of calcium sulfate by adding H2SO4 and observe that additional precipitate forms in the beaker. Explain this observation. So what happens, like this is calcium sulfate and it is forming calcium plus 2 ions and sulfate ions. So when you are adding sulfuric acid, so sulfuric acid is going to be H2SO4. When it is dissolved in water, it is going to form 2 hydrogen ions, aqueous form, plus sulfate ions in aqueous form. So you can see there are common ions. Sulfate is a common ion. So when you are adding more H2SO4, so there will be more sulfate ions, so its concentration will be increased and the equilibrium will be shift towards left hand side, so there will be more precipitate of calcium sulfate that would be formed. So how I'm going to write it? So this is going to be the right explanation, that additional precipitate of calcium sulfate that forms in response to increased sulfate ions in solution according to Le-Chatterjee principle, the equilibrium shift towards the formation of calcium sulfate solid. So in this question they are saying that there is a movable piston at the top and there is oxygen gas present there. There is a valve. A student investigate gas behavior using a rigid cylinder with a movable piston of negligible mass as shown in the diagram above. The cylinder contains 0.325 mole of carbon dioxide and the cylinder has a volume 7.95 liter and at 25 degrees Celsius and 1 atm calculate the density. So density is equal to mass by volume. For mass we have to multiply mole with the mr. mr is 32, 0.325 times with the mr, that is 32, and that comes out to be 10.4 gram of O2. Density is equal to mass by volume, so 10.4 gram divided by volume is going to be 7.95 liter, and that comes out to be 1.31 gram per liter. Moving towards the next question, attempting to change the density of O2, the student opens the valve on the side of the cylinder, pushes down on the piston to release some of the gas, and close the valve again. Temperature remains constant. Will this action change the density of a gas remaining in the cylinder? So first of all, he is trying to push the piston downwards. That means volume decrease. So volume decrease there. And he is also opening the valve, so mass also decrease. And as you know that density is equal to mass by volume, so if mass decrease, volume is also decreasing, so no change in density would be there. No change in density. Why no change in density? As temperature and pressure remain constant. So we can write the explanation in this way. So this is going to be the right explanation for that. So next question, they are saying the student tries to change the density of O2 by cooling the cylinder to minus 55, which causes the volume of gas to decrease. Using principle of kinetic molecular theory, why the volume of O2 decrease when the temperature decrease to minus 55. So what happens as the gas cools, then the average kinetic energy of O2 molecule decrease, because temperature like kinetic energy is directly proportional to temperature. If temperature decrease, kinetic energy also decrease, and the molecules which are going to have less energy, when they collide with each other and with the wall of the container, the spacing between particle decrease and would cause the volume occupied by the gas to decrease as well. So this is going to be the right explanation, that as the gas cools, the average kinetic energy of O2 molecule decrease, because kinetic energy is directly proportional to temperature. The molecules with less energy, when they collide with each other and with the wall of the container, then what happens when they are having less energy? The spacing with particle decrease, because molecules try to come close together, causing the volume occupied by gas to decrease. The student further cools the cylinder to minus 180 and observe that the measured volume of O2 is substantially smaller than the volume that is calculated using ideal gas law. For ideal gas law says that that molecules have no force of attraction, have no force of attraction between them. So but when the molecules will cool, their particles will come close together and force of attraction starts to develop over there. And because of this, you are going to see the intermolecular forces will be developed there and would result in inelastic collisions. How I'm going to write the explanation? So this is going to be the right explanation that ideal gas law assume that gas particles do not experience interparticle attraction. As a real gas cools further, the intermolecular force have greater effect as the average speed of molecule decrease. So when the speed of the molecule decrease, then the volume will also decrease.